In this video, we're going to take a look at a few different strategies that you can use for fraction division. The first thing we're going to look at is how you can use pictures to help you solve division problems. Using pictures is easiest when you have a problem like 3 divided by 3/4. It's really easy to use this method whenever you have a whole number as your first number that you're splitting up into fractional parts. If I were trying to solve this problem with pictures, I would first begin by drawing 3 holes because that is what the amount I have to start with. So I might draw circles, 1, 2, 3. Some of you might also like drawing boxes or something like that. Now, I've started with my 3 holes. I know that that's what I'm going to draw because that's the amount I'm starting with, the first number in the division problem. And I want to see how many groups of 3/4 will fit into 3 holes. So I'm going to split my 3 holes into fourths. Do it just like this. And now you can see that while I still have 3 holes, I have split them into fourths. Next, I want to see how many groups of 3/4 I can get out of the 3 holes. So if I color them in, I can see here's one group of 3/4. Here's another group of 3/4. I have a third group of 3/4. And I can create yet another group of 3/4 by coloring in 1/4 on each of the holes, the fourth that was left over. So I can see now that I have 1, 2, 3, and 4 groups of 3/4 in 3 holes. So I can conclude that 3 divided by 3/4 equals 4. Again, this method is easiest if you're starting with a whole number. The next method you could use is turning fractions into fractions with a common denominator in order to divide. For example, if I have a problem like 4/7 divided by 2/3, it's not very easy to make a picture for this because it's hard to divide something like 4/7 into thirds and see how many groups of 2/3 go in. So I'm going to use the common denominator method. So what I'm going to first do is change these fractions into fractions with a common denominator. I'm going to find the least common multiple of 7 and 3 in order to do so. I know that 7 and 3 don't share any factors but 1, so now I'm just going to multiply 7 times 3 to get the LCM. So the LCM equals 21, and that's what my new denominator is going to be. So I want to know, how do I change 4/7 and 2/3 into fractions over 21? So I'm going to use a giant 1 and say, what times 7 gives me 21? And I know that 7 times 3 is 21, so I'm going to use a giant 1 of 3 over 3. 4 times 3 is 12. So this means that 4/7 equals or is equivalent to 12 over 21. I'm going to do the same for 2/3, make my giant 1, and turn it into a fraction over 21. 3 times 7 equals 21, so my giant 1 will be 7 over 7. 2 times 7 is 14. So I now have 12 over 21 divided by 14 over 21. I'm going to rewrite that here. 12 over 21 divided by 14 over 21. Now, when I look at the denominators, I see that they are the same, 21 and 21. 21 divided by 21 is just 1. So I know that my answer is going to be 12 divided by 14. Now, 14 is not a factor of 12, so I'm going to end up with a fractional answer. Because my denominator is 1, I can simply rewrite 12 divided by 14 as 12/14. And if I choose to simplify, I can divide by a giant 1 of 2 over 2 and find my answer of 6/7. So again, using the common denominator is easiest when you have fractions that are not mixed numbers and when you can easily find a common denominator. The third method we can use, I like to call the keep, change, flip method. And this is a good method to use if you have mixed numbers. So if you have a problem such as 2.5 divided by 3/4, we might want to use the keep, change, flip model. Now the first thing we're going to have to do is change 2.5 into an improper fraction. If you're having trouble remembering how to do that, please see the video how to change a mixed number into an improper fraction. I'm going to do 2 times 2, which is 4. 4 plus 1 is 5. So 2.5 is equivalent to 5 halves. So I can change this to 5 halves divided by 3/4. Now the idea behind the method of the keep, change, flip model is that if we have a problem such as 10 divided by 2, our answer is 5, right? So if we have 10 items, we divide them into 2 groups, there would be 5 in each group. We also know that 10 times 1/2, or 1/2 of 10, is also 5. So this idea shows us that we can multiply a number by the reciprocal of the division problem. So 2 and 1/2 are reciprocals. That means they're the flipped versions of each other. So if we have 10 divided by 2, it's the same as multiplying by that reciprocal. We can apply this to our fraction division as well. So now we have 5 halves divided by 3/4. In this method, we keep the first number, 5 halves. We change the division sign to a multiplication sign, and we flip the last fraction, or we find its reciprocal, so it would just be 4/3. We just switch the numerator and denominator. Now, if you remember how to multiply fractions, you know that we just multiply across. So 5 times 4 is 20. 2 times 3 is 6. And we get a product of 26. We can change this improper fraction now to a mixed number. Again, if you're not sure, see the video. I say, how many times does 6 go into 20 without going over? I know 3 6s are 18, so I'm going to take 18 out, and I'm left with 3 2/6. If I wanted to go even further, I could simplify 2/6 by dividing by a giant 1 of 2/2, and my answer would be 2 1/3. So when you're looking at a problem, you want to think to yourself, which of the 3 methods makes more sense? Does it make sense to draw a picture to solve the fraction division problem? Does it make more sense to find a common denominator? Or does it make more sense to you to use the keep, change, flip model? Once you decide that, go ahead and have fun dividing those fractions.